Function notation. Recall that in a function every element of the domain is paired with exactly one element of the range. That is, for every value of x there is exactly only one y value. Function notation is a way to name a function using f of x instead of y. To make a general statement, we call the process by a letter such as f, and we can call the results of that process f of x. We write f of x as f of x, f parentheses x. The function can be named using any letter. Though f and g are used often, using function notation we can graph more than one of the functions at any time. If we call one function f and another g, then we can call graph y equals f of x and y equals g of x on the same coordinate plane. Let's look at an equation as a function notation. Given a function represented as an equation involving x and y, we can write y equals negative 3x plus 1 as a function. To represent y equals negative 3x plus 1 as a function, first replace y with f of x. It is read f of x and the letter of f is the name of the function, not a variable. Function notation is used to emphasize that the function value f of x depends on the independent variable x. The letter f is not the only letter you can use to represent a function. Key concepts. Functions can be evaluated at values and variables. To evaluate a function, substitute the values for the domain for all occurrences of x. To evaluate f of 2, replace all x's with 2 and simplify. The result is an ordered pair of a function and a point on a graph of the function. Let's look at an example. If we let f be a function with a domain 1, 2, and 3, and let f of x equals 2x. To evaluate f over the domain 1, 2, and 3, we will write the following equations by substituting each value in the domain for x. So we have f of 1 equals 2 times 1, which equals 2, f of 2, which equals 2 times 2, which is equal to 4, f of 3 equals 2 times 3, which is equal to 6. And you can see that I included a table within this slide so that you can see what it looks like as well. So therefore our range values of f of x is 2, 4, and 6. Here are some steps that you may want to use when evaluating a function. Step 1. Evaluate the function over the domain by substituting the values from the domain into the function. Step 2. Collect the set of outputs from the inputs. Your answers from step 1 will become your outputs or range. So, to evaluate f of x equals 4x minus 7 over the domain 1, 2, 3, and 4, to find the range, we will evaluate f of x equals 4x minus 7 over the domain of 1, 2, 3, and 4 by substituting the values from the domain into the function f of x equals 4x minus 7. So we evaluate f of 1, and by substituting in f of 1, we get f of 1 equals 4 times 1 minus 7. Then f of 1 equals 3, negative 3. Here we're going to evaluate f of 2. So to evaluate f of 2, we substitute 2 in for x. Therefore, we get f of 2 equals 4 times 2 minus 7. And we get, for f of 2, we find that y is 1. When we evaluate f of 3 in the equation, in the function of f of x equals 4x minus 7, we substitute 3 in for x and we get 4 times 3 minus 7, which gives us a range of 5. So the range so far is -3, 1, and 5. Now to evaluate f of 4. When we evaluate f of 4 by substituting 4 in for x, we get f of 4 equals 4 times 4 minus 7, which we get f of 4 equals 16 minus 4, which equals 9.